Okay, today we're going to talk about an element you probably haven't thought much about since, I don't know, high school chemistry class. It's not flashy like gold or famous like carbon, but it's quietly shaping our world in some of the most powerful ways you can imagine. So let's pull back the curtain on the hidden story of boron. And to get started, here's a little puzzle for you. What in the world do these three things have in common? You've got the super tough glass in your oven-safe dishes. Then you've got the ignition system for the massive rockets that took us to the moon. And finally, a totally cutting-edge therapy that targets cancer cells. I mean, they seem completely unrelated, right? Well, the secret, it lies in an element that honestly usually just looks like a dull brown powder. But hidden from our eyes, it has one of the most bizarre and beautiful atomic structures in the entire periodic table. A complex, mind-bending network of intricate little cages. And the answer, of course, is boron, atomic number 5. It's a metalloid, which means it's kind of part metal, kind of part non-metal. And that little chemical identity crisis, that is the very source of all its power.
So how does this totally unassuming element pull off such incredible stuff? Well, it all comes down to its truly bizarre atomic structure. And this isn't just a simple stack of atoms like you might picture. No, this is a masterpiece of chemical engineering.
So to really get boron, you first need to know about something called allotropes. Think of them as different outfits for the same element. You know, carbon, for example, can be soft gray graphite like in your pencil, or it can be an ultra-hard clear diamond. Both are just carbon. Well, boron takes this to a whole other level, with a bunch of known allotropes, and each one has its own unique properties.
And the fundamental building block, the absolute heart of most of boron's forms, is this beautiful 20-faced shape called a B12 icosahedron. It's literally a cage made of 12 boron atoms, and this super intricate structure is the real source of boron's incredible strength.
But here's the catch. To build a stable structure, you need electrons to act like glue. And each boron atom only has 3 of its outermost electrons, its valence electrons, to share around. That's just not nearly enough to form the normal chemical bonds with all its neighbors. It's like trying to build a giant Lego castle with only a handful of bricks. So, how does it do it?
The answer is one of chemistry's absolute cleverest workarounds. It's called electron-deficient bonding. See, instead of a typical 2-atom bond, boron forms these 3 center bonds, where 3 atoms share just 2 electrons. Think of it like 3 friends all sharing one slice of pizza. It's not a lot for any single person, but it keeps the whole group together. This brilliant trick is what lets boron build its strong, stable, and unbelievably complex structures. Now, this unique atomic arrangement isn't just some cool scientific trivia. It translates directly into a set of incredible physical properties, what you might as well call boron superpowers.
First up, it is ridiculously hard. Crystalline boron scores about a 9.5 on the Mohs hardness scale, and to put that in perspective, that puts it right up there as one of the hardest pure elements there is, second only to diamond. Yeah, diamond.
Okay, let's put boron up against a material we all know pretty well, steel. It's more than twice as hard. It has a melting point that's hundreds of degrees hotter, and yet it's over 3 times less dense, so it's way lighter. Hard, heat-resistant, and lightweight. That combination is the magic formula that makes it so valuable. And because of those amazing properties, boron isn't just stuck in a lab somewhere. It is a workhorse element found in countless technologies we use every single day. Let's go on a quick tour. So, where does all the boron mined in the world actually go? Well, this chart shows that more than half of it, 56%, goes into making glass and fiberglass. That's the single biggest use by a long shot, with ceramics, agriculture, and even detergents also being pretty big players. So let's talk about boron as the strength hero. It makes materials tougher. It's the key ingredient in fiberglass, which is used for insulating our homes and even building boats and cars. It's also what gives borosilicate glass, like Pyrex, its incredible resistance to thermal shock. That's why you can take a dish right from a hot oven and put it on the counter without it shattering into a million pieces. Now, when it comes to being a hardness hero, boron's compounds are legendary. Boron carbide is so hard it's used in military body armor and for industrial cutting and grinding tools. And then there's cubic boron nitride, a material so tough it actually rivals diamond, making it what we call a super abrasive for heavy-duty machining.
Boron is also a master of control.
The isotope boron-10 is exceptionally good at soaking up neutrons, which makes it absolutely essential for the control rods that regulate nuclear reactors and prevent meltdowns. And in the tech world, it's used to dope silicon, which is just a fancy way of saying we add it as an impurity, to change its electrical properties, creating the semiconductors that are fundamental to literally all modern electronics.
And what about being a power hero? Boron is the critical component in neodymium magnets, the strongest permanent magnets known to exist, powering everything from the tiny speaker in your phone to the motors in electric vehicles. And oh yeah, a boron compound was used to ignite the monstrous engines of the Saturn V moon rocket, because it bursts into flames the second it touches the air. How cool is that?
And believe it or not, boron is also a health hero. In a really clever type of cancer treatment called boron neutron capture therapy, a special boron compound is delivered directly to a tumor. Then, when doctors bombard it with neutrons, the boron atoms release targeted cell-killing radiation right where it's needed, sparing the healthy tissue around it. It's also an active ingredient in several powerful drugs.
So boron is already a hero, hiding in plain sight. But its story is far from over. Right now, scientists are exploring brand new ways to harness its unique properties, ways that could really define our high-tech future. Just look at what's on the horizon. Magnesium diboride is a remarkable superconductor that works at warmer temperatures than most. Boron-11 is being researched as a potential fuel for clean nuclear fusion, the holy grail of energy, a reaction that could produce power without creating long-lived radioactive waste. And out in space, electronics made with a special depleted boron can resist damage from cosmic rays, making our satellites and spacecraft way more reliable. It really is an incredible journey, isn't it? What starts out as a simple, pretty unimpressive powder reveals itself to be a material of immense complexity and power, one that's becoming more and more essential to all of our technological progress.
Which leaves us with one final question. With all its potential in everything from clean energy to space exploration, could this overlooked element actually turn out to be one of the most important and transformative materials of our time? It really seems like the story of this hidden hero is just getting started.